Welcome back for our second video on pages 64, or this one will be on page 64. The following figures are similar. Describe the sequence that shows the similarity between them. So these are not only similar, they are actually congruent as well. And so you know that since they're the same size, that it's not going to be a dilation, that it either needs to be a reflection, a rotation, or a translation. So when we look, here's B and then here's B prime, or the new B. And so basically what they did is they took the triangle and they flipped it on the x-axis. So to describe what happened here, the line of symmetry is the x-axis. And so you will write reflected on x-axis. And that's all you have to do. You're just describing what happened. Looking here, you can tell that they took the triangle where B is on the top and they have rotated it. And since it's in the different, the opposite quadrant, you know it's going to be 180 degrees. You can also check that with the points. 1, 2, 3. So this is a -3, -1. When you are doing a 180 degree rotation, you're actually just making both of the signs opposite. So it went up 3 and over 1. So this one, rotating 180 degrees. And you could probably use that little symbol trick to get the degree symbol if you want. Okay, now here, oops. On the bottom of this page, this time, oh my goodness, they are different sizes. So since they are different sizes, you know it's going to have to be a dilation. So here's how you can figure that out. If you look at the ordered pair A, which is 1, 2, 3, 4, 5, 6, 7, 8. So it's -8, 1, 2, 3, 4, 5, 6. So that's the first one. It's -8, 6. And then the second one is 1, 2, 3, 4, and then 1, 2, 3. So it changed it to a -4, 3. And so then you have to think about, I'm going to scoot this up a little since that's at the end of the screen. You have to think about what math you have to do to take your original, which was -8, and change it to -4. And so that's like solving an equation. So it'd be like -8 times what gives you -4. And when you do that, you could divide both sides by 8, and you would see that x would equal 1/2. And so the dilation, the scale factor, is 1/2. Now remember, if it starts bigger and gets smaller, you know your scale factor has to be less than 1. So maybe you accidentally flipped these. You would have got a scale factor of 2, but since it started big and got small, you would want to do the opposite and say the reciprocal. So 2, flip it, would be 1/2. Okay, looking at this one. Move me to the other side of the screen. Again, you can tell that these are different sizes. And so if I look at A, I see right now that A is at -1, 2. And then my new A is at 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So it changes it, draw a cute little arrow here, to -4, 8. So then the math I want to do is, what did I have to multiply the original by to get the new one? So -1, oops, that should be, oh, it's because it's there. Or I should just stretch it, right? I'll get this figured out some point. Okay, whatever. So -1 times what makes it -4. So then, again, I know I was running out of room down there. What you can do is you can divide. Oh, on the wrong page. I'm having a hard time today. Sorry about that. You can divide both sides by -1, and then you would see that x equals 4. So you would say dilation with scale factor of 4. Stretch that out so it's not. And then you would have your answer. So you look at you get both ordered pairs, find out what did you have to times. -1 times what gives you a -4. The answer would be 4. And so that's your scale factor.